Okay, here's the solution to Edx M2 January 2010 question 1 on the topic of general motion. Now I've actually written the solution out already, but I will just point out the main thing you've got to realize about this question. It's a fairly straightforward question once you realize this fact. As you read through the question, you'll see, first of all, it tells you the velocity of an object, a particle at time t. It also tells you that at t is 0, it's going through the origin, so s equals 0, where s is the distance from the origin. And we've got to find the distance of p from the origin when it's moving with minimum velocity. Now, minimum velocity will be when the acceleration is 0, as indeed would maximum velocity be. It's only the same as pure maths when if you wanted to find a min or max value of y in terms of x, those turning points happen when dy by dx is 0. So for v in terms of t, turning point happens when dv by dt is 0. And if you think about it, it's obvious, because if the acceleration is 0 instantaneously, then it has reached a max or a minimum point. If it wasn't 0, the velocity would be increasing or decreasing. So using the fact that we've decided dv by dt is 0, all we have to do now is find dv by dt by differentiating, and that gives us t equals 2/3. So now we know that we need to find the distance when t is 2/3. So we've got a choice. We have to integrate, but we've got a choice whether we integrate between limits or integrate indefinitely and find c, which is what I've done. So to find distance from velocity, we have to integrate the velocity, and this is the steps involved with that. So just check that integration. I've done it indefinitely and put a plus c at the end. But it's nice and straightforward, because when t is 0, s is 0, so c is 0. So the expression for displacement, or distance in this case, they're using the phrase distance, so s equals t cubed minus 2t squared plus 3t. And all we have to do is put t equals 2/3 in there to give us the required answer. Okay. We could have integrated, back here, we could have integrated between the limits t equals 0 and t equals 2/3. That would have been an equally good way of doing it. I've already indicated on here the mark allocation. There was a total of 8 marks. As you can see, there was a method and accuracy mark for writing down the acceleration, dv by dt is 6t minus 4. And correctly putting that equal to 0 and finding t, another 2 marks for that. Then there was 2 marks, 1 method, 1 accuracy for integrating. And finally, 2 marks for putting the correct value of t, 2/3, into the expression for s and finding the correct answer. So that's that question done. Hope that was of some use. Here's some information about the Further Maths support program.